In this final video for Unit 2, Lesson Set 3, we're going to look at the average rate of change of a function and finding the equation for a secant line. So when we want to find the average rate of change of a function, if a and b are not equal to each other and are in the domain of a function y equals f of x, the average rate of change from a to b is defined as f of b minus f of a divided by b minus a. And if you notice, f of b is really the y value for the function, and f of a is a y value for the function. So what you're really doing is solving for slope. So the average rate of change is slope. And we know a cannot equal b because then our bottom value would be 0, and we can't have that. So the triangle is a symbol that means delta, or the change in value. So when we want to solve for average rate of change, let's look at this example. Find the average rate of change of f of x equals 3x squared. So they gave us the equation and the function, and we want to know what the average rate of change is for a from 1 to 3. So first off, we need to figure out what f of 1 is. Now, we could plug 1 into x, and we know x squared, 1 squared is 1 times 3 is 3. Or because we have the graph, we could simply go over here and look at 1 and see what our y value is, and it's 3. So when we go over to 3 and up, we see our y value is 27. And then we take our delta y divided by delta of x. Basically, we're subtracting what f of 3 is minus f of 1. And you put your 3 and your 1 on the bottom. Notice that they match up. Plug in the 27 for f of 3 minus 3 for f of 1, and we end up with a value of 12 as our rate of change. So let's look at b. b wants to know from 1 to 5. So we know that f of 1 equals 3. Go over to 5 and up. F of 5 equals 75. Plug it into our average rate of change equation. So f of 5 minus f of 1 over 5 minus 1 will give us a rate of change of 18. So the secant line. The secant line is a line that contains the 2 points a, f of a, and b, f of b. So remember, with this, f of a is the y value. F of b is the y value that goes with the x value of a and the x value of b. And the secant from the function y equals f of x, this is called the secant line, and its slope. So our secant slope is f of b minus f of a over b minus a, which is the same thing as saying f of a plus h minus f of a divided by h. So when we look, we see our secant line goes through the 2 points that we found our average rate of change for. So basically, this theorem for the secant line states that the average rate of change of a function from a to b equals the slope of the secant line containing the 2 points a, f of a, and b, f of b on its graph. So let's look at an example of this. Suppose that g of x equals 3x squared minus 2x plus 3. For a, we want to find the average rate of change of g from -2 to 1. Now, in this case, we were not given a graph, so we are going to have to solve g of -2 by plugging -2 into our function for x until we get a value of g of negative 2 equals 19. We're going to need to do the same thing for g of 1. So we plug in 1 where our x's are in our equation, in our function, and we get g of 1 equals 4. And the first thing that we need to do to find the average rate of change is we need to find the delta y divided by the delta x. So that would be g of 1 minus g of negative 2, and then 1 minus negative 2. And that's going to give us a value of negative 5 as our rate of change. And remember, we stated that rate of change, that is our slope for our secant line. Okay, so that is our slope for our secant line. So now to find our secant line, we need to take this slope and we're going to plug it into the point slope formula. So what I like to do, I like to take the information from the previous example. So we know g of negative 2 is 19. So I'm going to put it in just to make it easier for me to solve. So I have an x and a y value. And I did the same thing for g of 1. I found my x and my y value. So this makes it easy for me to determine when I want to plug into the point slope formula, I want to choose one point to plug in for x1, y1. And I'm just going to choose 1, 4, just because they're smaller numbers and easier to work with. So I plugged in the y value of 4 for y sub 1, and I plugged in 1 for my x sub 1 value, and then I took my average rate of change, my secant slope, and plug that in for my m secant. And then from there, it's all just simplification, just like you've done in all your other algebra classes.